In this video, we will look at the role of Muslims in astronomy. But before that, I have a message from today's sponsor, Brilliant. Brilliant is my favorite way to learn something new because it makes learning really fun and engaging. It's an interactive online learning platform with thousands of lessons in math, science, and engineering. And all our lessons are presented as fun puzzles and games. So instead of getting bored and distracted, I actually enjoy learning with Brilliant. The reason I love Brilliant so much is that they make learning easy and fun. They teach you by breaking down complex topics into bite-sized pieces, and then they ask you questions after each little chunk of information to make sure that you understand what they just taught you. You can learn at your own pace and at any time. They also have a mobile app, so you can learn anywhere. If you have kids, they even have special courses designed for kids. This course teaches kids the basics of programming by having them create their own games. Whether you want to know more about solar panels or neural networks, Brilliant has a course for you. Right now, you can sign up for free using my link, Brilliant.org/Salman, and get 20% off an annual premium subscription. And the first 200 people to use my link will get 20% off Brilliant's annual subscription. Now let's get back to the video. Before the scientific revolution of the 16th century, most astronomical knowledge was known to the ancient Greeks. Most of these ideas were collected in a book called the Almagest written by Ptolemy. This book remained the standard textbook in astronomy until the 15th century, 1400 years later. While the Greek astronomers had made some incredible discoveries, such as the phases of Venus and the fact that the Earth is a sphere, they also believed that the Earth was the center of the universe, and that everything else revolved around it. This model was called the geocentric model. Other astronomers like Aristides had rejected this idea long ago, but his work was lost and nobody knew about it. Meanwhile, across the world in India, China, and the Islamic world, scientists were making great strides in mathematics, physics, and astronomy. In this video, we will focus on the contributions of the Muslims. By the end of this video, you will know why Muslims became the leaders in astronomy, how they calculated the circumference of the Earth, how they discovered the rotation of the Earth, how they mapped the stars, and finally, what they discovered about the nature of the universe. The Muslim Golden Age lasted from the 8th to the 13th century, starting from the reign of the second caliph, Omar ibn al-Khattab, who conquered vast amounts of land for Islam. Underneath his rule and the rules of his successors, trade flourished between Europe, Africa, and Asia. During this time, Muslim scholars translated many Greek texts into Arabic and added their own commentary. This included the works of Aristotle, Euclid, Ptolemy, Galen, and others. They also kept the knowledge of the Greek astronomers alive during the dark ages of Europe when there was no scientific development. In fact, it was Muslim scholars who corrected and improved upon the flawed Greek astronomy. Al-Khwarizmi, one of the greatest Muslim scholars, helped to replace the Greek number system with the Hindu-Arabic number system. Without the introduction of the zero, positional values, and simple arithmetic, algebra, trigonometry, and calculus would not have been possible. In the 9th century, Caliph al-Mun ibn Rashid established an observatory in Baghdad and invited astronomers from all over the known world to come to Baghdad and study there. He also founded the House of Wisdom, where scholars from all over the world gathered. Muslim scholars collected data on the motion of the stars and planets and realized that Ptolemy's ideas were wrong. Ptolemy had said that the stars were attached to a crystalline sphere that rotated once a day, and he believed that the other planets, including the sun and moon, revolved around the Earth. They were able to prove that only the sun revolved around the Earth, not the moon or the planets. To explain the retrograde motion of Mars, Ptolemy had used epicycles, which was an incredibly complicated system of rotating circles. The Muslims developed the theory of tides and realized that the Earth was being pulled by the moon and the sun, and they were able to explain the retrograde motion of the planets without epicycles. They also provided evidence that the Earth was a sphere. Al-Biruni, a polymath of the 10th century, calculated the circumference of the Earth to be 24,660 miles, almost exactly the modern value. He did this by measuring the change in angle of Polaris, the North Star, as he traveled south. His method was similar to how we measure the height of a mountain. We take the points at different elevations and use trigonometry to calculate the difference in heights. But instead, Arbery measured the angle of the North Star from the equator and from a location further south. Then he used trigonometry to calculate the radius of the Earth. In the 12th century, Ibn al-Haytham, also called al-Hazan, wrote a book called Kitab al-Mutasar fi Hisab al-Shuyuk, or the Compendium Book of the Elements of Astronomy. This book was used for centuries and was the basis of astronomy for both the Muslims and the Europeans. It contained the collected works of previous astronomers as well as his original research. In this book, he described how shadows showed that the sun's rays were parallel, that the sun was very far away, and that the earth was curved. He also studied eclipses and explained them without invoking astrology. This book influenced the scientific revolution of the 16th century when European scholars rediscovered it. It inspired the astronomer Tycho Brahe, who built the first observatory and collected accurate data on the motion of the planets. Another astronomer who lived in Maragh, Iran, was Al-Tusi. In the 13th century, he rejected the prevailing view that the Earth was flat and proved that the Earth was a sphere. He did this by showing that the length of a degree of latitude decreased as one went further north. This was because the Earth was curved. Tosi was also the first to discover the parallax of stars. Parallax is the apparent shift in position of an object when viewed from two different locations. For example, if you hold your finger in front of your face and close one eye, then switch to the other eye, you will see that your finger appears to jump from one position to another. This is because your two eyes are in different positions and they are capturing slightly different angles. Similarly, when you look at a star from two different locations, such as the 2 points on the Earth that are diametrically opposite, the star will appear to move relative to the background stars. However, this movement is too small to be seen with the naked eye. And it wasn't until the 19th century that an instrument called a transit telescope was used to measure the parallax of nearby stars. Even today, we rely on parallax to measure the distances to nearby stars. In the 10th century, Al-Idrisi, a Muslim geographer, created a world map that was incredibly accurate for its time. It is now known as Tabula, Georgiana, or the Hereford Mappamundi. This map was commissioned by the King of Sicily, and it shows the known world, including Africa, Europe, Asia, the Middle East, and even the Americas. Although the Americas were not known in Europe at the time, El-Idrisi included them on his map based on information from Arab sailors who had explored the coast of North America. This map is notable for its accuracy and detail. It shows cities, rivers, mountains, and other geographical features with remarkable precision. In fact, it is one of the most accurate maps of the world ever created before the Age of Exploration. El-Idrisi was born in 974 AD in a city called Medina. He began studying geography, astronomy, and cartography at a young age and traveled extensively throughout the Muslim world to collect information for his maps. He died in 1040 AD, but the exact date of his death is unknown. Muslim scholars also made significant advances in optics. In the 11th century, Ibn al-Haytham, who was already mentioned before, wrote a book called Kitab al-Manazir, or the Book of Optics. This book was a comprehensive study of the properties of light and vision. In it, Ibn al-Haytham discussed reflection, refraction, diffraction, and other properties of light. He also explained how images are formed in mirrors and lenses and was the first to discover the law of conservation of energy in optics. Ibn al-Haytham's work had a profound impact on the development of optics and was influential in the work of later scientists such as Roger Bacon and Leonardo da Vinci. His ideas helped to pave the way for the scientific revolution of the 16th century and the development of modern optics. The last thing that we will talk about is the Muslim astronomers' discovery of the solar system S-shape. Over the centuries, Muslim astronomers realized that the universe was not static and that the Earth was moving. Instead of being at the center of the universe, they placed the sun at the center of the solar system and theorized that the Earth and other planets were revolving around it. Unfortunately, the Christian theologians of Europe rejected heliocentrism because it contradicted the biblical account of creation. They believed that the earth was created on the fourth day and that it was special because God had created it on the fourth day. This was considered a sin against God, and those who supported heliocentrism were persecuted. As a result, the heliocentric theory was kept secret and was not widely accepted until Galileo came along several hundred years later. And that's all for today. I hope you enjoyed this video. If you did, please make sure to leave a like. Also, remember to subscribe so you don't miss out on future videos. If you have any questions or comments, feel free to leave them below. Thank you for watching, and I'll see you next time.